Welcome to Beans and Bedrock.
Hello everyone and welcome back to Beans and Bedrock. I hope you're all doing great. My name is Anupam and on this channel we dig into software engineering, Java, Spring, AWS and AI, one topic at a time. So let's get started. Today we're going to understand a really important topic in software engineering. As your objects grow, creating them turns into a tangled, fragile mess. And your code becomes painful to read and even more painful to maintain. The pattern that fixes this elegantly is called the builder design pattern. Alright, before we touch any code, let me ask you something. Think about the last time you ordered a sandwich at a place like Subway. You didn't walk up and say, "One sandwich, please." That's meaningless. The cashier has no idea what you want. Bread, meat, cheese, toasted or not. Instead, the process is step by step. White bread, please. Turkey. Cheddar. Yes, toasted. Lettuce, tomato, no onions. Mayo, light on the mustard. Each instruction adds to the sandwich. You're not forced to specify every single topping in one breath, in one exact order, and you don't get a sandwich you didn't ask for. Compare that to a hypothetical one-shot ordering system. You'd have to hand the cashier a slip of paper listing bread type, protein, 3 cheeses, or none, none, none if you don't want 3. 5 vegetables in a fixed order, 2 sauces, toasted yes or no, and a napkin count all at once, in the exact order the form demands, even if you don't care about 80% of those fields. Sounds ridiculous, right? That's frustrating, error-prone, and doesn't scale if the sandwich shop adds new options next year. The builder pattern is the Subway counter approach to constructing objects in code. It lets you build something complex piece by piece in a readable sequence, specifying only what you actually care about and only getting a finished product once every choice has been made. Okay, so that's the idea in the real world. Now let's see the actual problem this solves in code. Here's the technical problem the builder pattern was invented to solve. It's got a great nickname, the telescoping constructor problem. Imagine you are modeling a computer object. At first, it's simple, easy. 2 parameters, done. But then the requirements grow. Some computers have storage, some have a graphics card, some have Wi-Fi, some don't. Some have a specific number of USB ports. So you, the well-meaning developer, do what feels natural. You add an overloaded constructor for every new combination. Each constructor telescopes out from the last one, hence the name. And now you have a real mess. It's unreadable. Look at a call site. New computer, Intel i7 16512. True, false, 4. What does true mean? What does false mean? You have to go check the constructor definition every single time. It's error prone. 2 boolean flags next to each other are incredibly easy to swap by accident, and the compiler won't stop you. It'll happily compile the bug. And trust me, I've shipped that exact bug myself. It doesn't scale. Every new optional feature means either a new overload or forcing every caller to pass a value for something they don't care about. Optional parameters are painful. If a caller wants a graphics card but not Wi-Fi and doesn't care about USB ports, they still have to pass something for every parameter in between, in the exact right order. We need a way to construct this object that's flexible, readable, and doesn't force us into a combinatorial explosion of constructors. That's exactly what the builder pattern gives us. So, enough about the problem. Let's go build one. Alright, let's fix this properly. We're going to build a computer class using the builder pattern, step by step. I'll explain every line. Nothing is skipped. Step 1, the product class. Private final string CPU and private final int RAM. These are our required fields. Final means one set, they can never change. This makes our computer object immutable, a safe, predictable object that can't be modified after creation. The optional fields: storage, has graphics card, has Wi-Fi, USB ports, work the same way. Final, set once. Private computer, builder. This is the key move. The constructor is private. That means nobody outside this class can call new computer directly. The only way to create a computer is through the builder. This forces every developer down the correct path. Notice the constructor pulls all its values from builder.cpu, builder.ram, and so on. It's just copying the finished configuration of the builder. And that's half the puzzle done. Now, for the star of the show. Okay, step 2, the nested builder class, public static class builder. This is a nested class living inside computer. It's static, so we can use it without first having a computer instance. Chicken and egg problem avoided. The builder's own constructor, public builder, string CPU, int ram, takes only the truly required fields. This is intentional. Anything essential to a valid computer gets forced up front, right in the constructor call. No computer can exist without a CPU and RAM. The optional fields: storage, has graphics card, has Wi-Fi, USB ports, come with sensible defaults already assigned. If the caller doesn't mention them, these defaults are what get used. Each setter method, storage, has graphics card, and so on, does two things. It stores the value and it returns this, returning the builder object itself. This return this is the trick that makes the whole pattern click. Because each method hands back the builder, you can chain calls together, one after another, like links in a sentence. This chaining style is called a fluent interface. Finally, public computer build is the method that says, I'm done configuring. Give me the final object. It calls the private computer constructor, passing itself in, and that constructor copies all the values across. Once build returns, you have a fully formed immutable computer. That's all the machinery. And honestly, this next part is my favorite. Step 3, using it. Just look how clean this is. New computer.builder Intel i9 32. We start the chain, supplying only the required CPU and RAM. .storage 2000, we explicitly want 2 terabytes of storage. This overrides the default of 256. Has graphics card, true. We want a GPU, so we flip it from its default, false. USB ports, 6, we override the default of 2. Build, we finalize it. This is the only line that actually produces the computer object. Everything before it was just configuration. Notice has Wi-Fi was never mentioned for gaming PC. It silently keeps its default value of true. No error, no placeholder value, no confusion. Now look at budget laptop, required fields only, everything else defaults. One line. Zero ambiguity, about which true or false means what. Compare that to what we would have had with telescoping constructors. That's the whole point. Same object, same data. But one version documents itself and the other makes you guess. Okay, we saw all of this. Let's quickly do a recap. The problem: constructors with too many parameters, especially optional ones, become unreadable and error prone. That's the telescoping constructor problem. The fix: a separate builder object that collects configuration step by step through chained method calls, then produces a final immutable object via .build. The payoff: self-documenting code, safe defaults for optional values, and a construction process that scales cleanly as your object grows more complex, and that's the builder pattern. Simple idea, massive readability win. Try it on the next class you write with more than 3 constructor parameters. You'll feel the difference immediately. See you in the next one.